We have Ms. Joy Boya. She's a skilled and creative data scientist with a background in petroleum engineering, graduating with first-class honors.
Hi, good evening, everyone. Israel, thank you for that introduction. I'm so excited to be here this evening. I'm sure we are all excited. So I'll be taking us through the agenda for today's technical meeting. So I'll be sharing my screen now. All right, so today's agenda, we've started with our national anthem, introduction of moderator. So next we'll be taking our safety brief, then our opening remark, recognition of senior members, introduction of speaker, after which we'll have the speaker's presentation, which will last for 35 minutes, and then 20 minutes for our question and answer. From there, we'll move on to photographs, and then our membership drive, our Kahoot quiz, of course, closing remark, and then we'll end with our national anthem. All right, so all right, so let's observe this safety precautions. So if you're not speaking, please don't unmute your mic. If you want to speak, please use the raising of arm signal. And if you have comments or questions, so this is an interactive meeting, so you can drop your comments or questions in the chat box. Use C to indicate comments and Q to indicate questions. If you're using a headphone, please make sure it's not too high. It's low enough for you to hear any alarm in your background. Stay alert of your environment, and of course, please do stay alive. Yes. So next, we're moving on to call our technical information chair to give us the opening remarks. So Dr. Jude Osimo will be giving us the opening remarks this evening. Dr. Jude, over to you.
Confirm you can hear me all right?
I can hear you.
Okay. Good evening, everyone. A warm welcome to another fantastic opportunity to learn. For every technical meeting you avail yourself the opportunity to be part of, it's as many topics and as many technical awareness, cum knowledge you carry. So I always encourage YP, especially when you have a forum like this, that SPA has benevolently provided for us. It's a wonderful opportunity to learn. So imagine how many topics you've learned since you joined SPA. Put them all together. You're somewhere between the awareness to knowledge, skill, competence in this topic. And as you can already see, a very fantastic topic have also been brought forward by a professional that knows it very well. This topic cuts across both what we do in the subsurface space and the environment space. We all know the conversation around keeping our environment safe these days. And then a technical and a smart way to do this is what we'll be talking about today. I'll leave the moderator and the speaker to do justice to it. But this is also to continue to encourage us. I'm looking at the attendance. I hope this message go out there the more, because the number of presentations you listen to, tomorrow when you hear subjects like this being discussed, or you see people talk about certain things, it doesn't mean that they've read it all. It just means that they avail themselves the opportunity to listen to experts. So take your pen and paper. As a student, as a YP, don't assume my questions are going to be stupid. If you don't feel very comfortable, the internet and this platform have made room for private questions. Any terminology you don't understand, ask. This is your best of time to learn. Anything that is not clear, please ask. Anything you don't understand very well and you need it to be deepened more, maybe time will not avail. Find the best of time to network. The organizers of this program could help you reach out to the speaker if need be. And all I'm saying is the technical depth that we talk about, it begins in programs like this. Don't let it just slide and go. As a YP, everything you learn, you'll be surprised tomorrow when you talk about this subject or choose to learn it the more. I'm also echoing the voice of the SC and the entire board members. Welcome and have a good evening. Back to you, moderator.
Thank you so much, Dr. Jude, for that thought-provoking opening remark. Please, let's show Dr. Jude some love in the comments, in the chat box. Let's show him some love, some applause. Next, we'll be moving to the recognition of senior members by our YP chair, our dear YP Mama, Ofuri Oguge. Let's give her some love in the comment section. Ofuri, over to you.
Thank you very much, and good evening, everyone. Really good to be here, and thanks to Israel for helping us kick off the session today. Promises to be an amazing one. Thanks to our speakers already on the call, and of course, Captain J, who just gave us the opening remarks. Welcome once again to the monthly technical series for January, YP series for January. And I see we already have some board members on the call. Thank you so much for joining. I'll start with Madam Imabong Basil, the WLP chair for SP section 103, the Women Leadership Program Committee chair. Thank you so much for joining. I also see our communications chair, Madam Dorcas Otis-Kuro. Thank you for joining. And of course, Captain J, Dr. Jude Osimobi, that just took the opening remarks. Thank you, Captain J, who's the Technical Information Chair for SP Section 103, Port Harcourt. I also see Iwuari. I think I saw her on the call. She's the Assistant Student Affairs Chair for this section. Thank you so much, Iwuari, for joining. And of course, we'll continue to recognize our senior members and board members as they join the call. The session promises to be great. I'm ready to learn and gain as much as possible from it. So please do well to also remind your friends, share the invites with people so they come join and learn together. Thank you all. Have a wonderful time here. I'll hand over now to our moderator.
Thank you so much, Ofuri, for that recognition of senior members. All right. So next we'll be introducing our speaker. We have a very notable speaker here today with us. He's Mr. Femi Obakena Ohiosume. Mr. Femi has over 11 years experience in the oil and gas industry, spanning across the oil and gas development spectrum from studies, execution, WRFM, and non-operated ventures. He holds a BSc degree in industrial chemistry from the prestigious University of Lagos, Akoka, in 2009, and an MSc from the Petroleum Production Engineering Robert Gordon University, Aberdeen, UK, in 2022. In his current role, he manages production from a major Niger Delta field with rich export gas production of 128 SCF per day of gas and over 25,000 barrels per day of oil and condensate from over 25 wells, with the gas accounting for over 70% of Shell Nigeria's daily export gas production to NNNG. Femi has strong petroleum engineering and production technology skill sets and expertise, sand control design and management experience, smart well design, operation and optimization. He currently operates and optimizes a few smart wells to realize their full value. He is he's also highly skilled in integrated production system modeling, production systems optimization, and practice of well, reservoir, and field management, with a proven track record of delivering greater than 20% increase in production systems capacity from activities for several years. Some of these success stories and best practices have been shared with the global communities of practice. He enjoys working in integrated and natural team and is an excellent team player, a goal-getter, passionate about coaching and development of peers and young engineers, taking part in mentoring young professionals in the SP mentoring program. Femi is married to his beautiful wife, Damilola, and are blessed with a daughter, Jemima, and 7 years old, and a son, Samuel, 4 years old. Wow. Please let's give our speaker a round of applause. We can see he's fully loaded, so we should expect a lot of knowledge and information this evening. I'm very excited. I hope you're all excited too. So if your hands are not too busy, I'd like you to drop some applause for him in the chat section, drop him some emojis, and welcome him as he comes to discuss with us on produced water disposal design, subsurface considerations. I'm sure this will be an informative session for everyone. Mr. Obakena, over to you.
Hello, please confirm me.
So I can hear you, but it's not very clear.
Okay, how is it now? Is it better?
Okay. Yes, it's better now. Please go ahead.
All right, I'll share my screen. And please also confirm you can see my screen, please.
Yes, I can see your screen.
All right, great. All right, so welcome. This is a topic and a project that is close to my heart. Fortunately, I'm one of the guys who's been fortunate to walk across this project right from the initiation. I was in the team when this project was initiated. And then during his execution, I moved to the team. I've been moving with it to the team that executed. And now that we're in the operate phase of this work, again, the team that is producing and managing this particular project. So it's produced water disposal and very dear to my heart, like I mentioned. But in this presentation, I'm going to be presenting So this is the outline that the presentation is going to be going through. I'm going to first of all be sharing the objective of the project and then the subsurface consideration for a robust produced water design, right from reservoir selection to the modeling, as well as the performance analysis. All right, so the objective, sometime in 2017, 2018, 2019, there was this update to the air gas spin standard by DPR. And one of the recommendations there was that instead of the overboard disposal of petroleum produced water, the new way of working would then be to develop a robust subsurface disposal of produced water. And that means wells will be drilled and all the produced water would then be discharged to a selected appropriate reservoir. So in Shell way of working to comply with this new standard, we went about developing a project, a pilot project that would do that. And in addition to complying with this new standard, it would also help us to continue to sustain production whenever our evacuation route is down. Usually when we produce in our field, the liquid is usually evacuated through a trunk line that takes it to the terminal where the separation of oil is done from water, the oil is exported, and then the water is disposed, as well as the gas is also sent for export. But because of the where we operate in the country, sometimes we have vandalism of these trunk line. And that means when that happens, we shorten our oil wells as well as our gas wells. So in addition to meeting the air gas pin standard, this project also enabled Shell to continue to produce, because now we can dispose the water through a produced water disposal well, while continue to meet our production of gas daily. So this is just the summary of that I've mentioned, just discussed in the previous slide. So in this project, we identified some wells that we could actually use to dispose the produced water. But what are some of the subsurface considerations if you want to design a robust produced water disposal system? Before I go into that, a brief overview of the field that I'm referring to. I have removed some names here, but some of my colleagues who are here would identify some of these. This is the asset where I currently work, and you can see how the fields produce the number of wells, oil wells, and gas wells. And you can see the huge volume of gas that we produce every day, about 1.4 BCF. And then the font in orange are the oil production. And you can see that the oil production is close to 55,000 barrels. And about that amount is the amount of water that we also want to treat and dispose in terms of the subsurface. This is a multidisciplinary project. I'm going to be presenting. I will take your questions and I'll try and answer them as much as I can. The first thing we do, if you want to design a robust produced water disposal, is to select an appropriate reservoir. In that same 2018 EGASPIN standard, DPR rolled out 3 criteria that must be met before a reservoir can qualify as a sink to dispose your produced water. One of them is that the reservoir must be depleted of commercial hydrocarbon. That means if you are producing from the reservoir, you have to demonstrate that that reservoir no longer contains commercial hydrocarbon. If it passes that condition, then the second condition is that that reservoir must be bound top and bottom by a competent shale, such that whatever you are discharging and disposing into that reservoir will be contained within that reservoir. So you need that competent shale. And then the third condition is that it must be deeper than the deepest underground source of drinking water. And that has been estimated to be 3,000 feet. So any reservoir that is deeper, that meets the first 2 conditions and is deeper than these 3,000 feet, such a reservoir can qualify as a produced water disposal reservoir. Now the table on the right just shows you those criteria put in a spreadsheet. So it's not a complex thing. All you need to do is put all your reservoirs in your field in a spreadsheet and put these ranking criteria and see if they all pass. Anyone that passes is a potential water disposal reservoir. Unfortunately, like you see in this table, most of the hydrocarbon producing reservoir did not pass. And that was because most of them still have commercial hydrocarbon, even though they met the last 2 conditions. So the next thing we do was to discuss again with the regulators, and we settled for a water-bearing reservoir. Now, the next thing you do is you have to then integrate this where you have, like what you see in the next figure, is a correlation panel that shows a stack of this reservoir, and then you can then demonstrate whether there is a bounding shale top and bottom of your selected reservoir. Like I mentioned earlier, we then settled on 2 water-bearing reservoirs that, of course, automatically the first condition of being depleted of commercial hydrocarbon no longer applies. Then the second one, that it must have a shale top and bottom of that reservoir, and the third one, that it must be deeper than 3,000 feet. And when we did that, these 2 reservoirs, the C2 and the C4 reservoir, passed the reservoir selection screening. And then the next thing we did was to then carry out what we then refer to as a caprock integrity analysis, which is the next section, the next subsurface consideration in building a robust produced water disposal system. Now, what we normally do here is you want to be able to tell that when you are beginning to dispose water into the selected reservoir, the caprock that you have top and bottom of that reservoir will be able to hold so that it would not frack and it will not shear as long as you continue to dispose water into your selected reservoir. And there are 2 major methods that you can use to carry out this caprock integrity analysis. If you have enough data, you can use a dynamic simulation model. And if you have limited data, there is this numerical or the more column method that you can use. For this project that I'm describing, the second method was used, but I will just briefly describe how both of the methods works. Like I mentioned, for the dynamic simulation method, you have an earth model which you integrate with a dynamic model that contains all the in situ stresses and forces and properties of the said reservoir. And what you can then do is you then simulate injecting water into the reservoir, and then the model will simulate the changes in the in situ pressures and properties of this reservoir and can tell you how long you can inject and how long it would take you for your caprock to stay intact without giving way. And then that will give you a kind of a sense check to see whether such a reservoir is okay to carry out, to serve for your water injection purpose. The second method is the Mo-column method. This one just contains a series of linear equations, which are plotted like you see in the figure on the right. What you then do is to plot the different scenarios on this plot. Any of the scenarios that crosses this your failure line, that scenario will fail. And that means if you subject your reservoir to that particular scenario in your injection process, then your caprock will not stay intact. The next slide just shows you, I won't dwell much on this, just show you some of these equations that go into building that Moore-Colomb failure criteria envelope. Okay, again, some of the properties that go into there. If you don't have, it is good that you have data from core, but if you don't have such data available, you can derive some of these parameters from your logs, especially if you have sonic log. You can derive your UCS and the rest. That's the unconfined compressive strength, your cohesion, your cohesive strength, and your friction angle, which you then use to build that Moore-Colomb envelope, and then subject such to the different scenarios of injection and see if any of them would fail. And this is what comes up when you do that scenario analysis. The first plot on the left are the pre-injection stage. So this is what you have. Now, normally, if you have enough data, you can draw the low, base, high failure line for your reservoir. And then you can then test your different scenario. And as you see, for the 2 reservoirs that we selected, none of the in situ condition, that's a pre-injection condition, you can see none, this rock is intact, no failure. But when you begin to subject it through water injection, and we tested six scenarios for the 2 reservoirs, you can see that for each of the two reservoirs, two cases crossed the low case failure envelope. And that means those two scenarios indicate that if you subject your reservoir to those injection scenarios, your cap rock will not stay intact. Yeah, so this does what this tell you. And then you can then design your water disposal injection system in such a way as to avoid those two scenarios. Or you can then carry out sensitivity analysis and see whether you can constrain those conditions so that they stay within and below your failure line throughout the injection into that reservoir so that your cap rock will stay intact. And you can also do probability analysis using the Monte Carlo simulation model. And what you normally see is that you can then plot the probability of failure. Like we did in this case, we tested 10,000 simulations. And when we did this analysis, you saw that close to 2,000 of those scenarios failed. And if you see the probability distribution below, you will see, and that accounts for 18% failure. That is huge. So what you can then do when you notice something like this is to play around those properties of injection, whether it is your injection pressure, injection rate, and do the simulation again and see whether your probability of failure reduces. And that will give you some confidence whether you can use that reservoir for injection. And then the next slide just shows you the sensitivity on only one of the properties, and that is the injection pressure. And if you look at the plot on the left, this is the plot I showed earlier for one of the reservoirs. That when we began to inject, two of the scenarios crossed the low case failure line. But then when we reduce the injection pressure, that's the water injection pressure, by 50%, you can see they just lie on the line. And that means that rock, that cap rock will be okay if we inject just by reducing the injection pressure by 50%. And if you then look at the probability analysis, you can see that the probability has reduced from that 18% to 2.4%. Instead of the close to 2,000 of those scenarios that we analyze are failing, only about 240 fail, and that is 2.4% probability of failure. And that gives you a high confidence that if you reduce your injection pressure, this is just one parameter, then you can go ahead and inject into that reservoir. And the conclusion is that the cap rocks are okay and they will not fail if you inject at this new pressure. So this is just to show you that you can then sensitize on your injection properties and see how your reservoir, especially your cap rock, behaves to such a change. The next very important thing that you do in designing a robust produced water disposal system is the fracture injection modeling, which is, the acronym here is produced water reinjection fracture modeling. There are several simulation models in the market. For Shell, we call it the PWRF frac. It is a 3D model, and I won't dwell on this. It just shows you some of the properties that go into that PWRF frac model, and they include geology properties, your reservoir properties, the water you want to inject, the properties itself. We also go into this PWRF frac modeling. And what that really tells you is it is able to tell you, as you inject into the reservoir, how your fracture will grow over time. And if you look at the first plot on the right, you can see the wavefront telling you how your fracture length increases with time. The time are in months. So you can see this was done for up to 30 years. So you can see how the fracture length keeps increasing over time. And then the plot on the right tells you where your fracture grows into. If you look at the reservoir here, the orange color reservoir is the reservoir of interest, while the lines up and down are the cap rock that bound this reservoir. And you want to frack your reservoir so that you can inject more, but you don't want that fracture to grow into your cap rock and render your cap rock useless. But if you look at what we see here, whether the fracture initiation started at the top or bottom or at the middle of the reservoir, for all the three cases, you see that they grow into your caprock, and this is not what you want to do. You want your fracture to remain within your reservoir. This is what this PWRF fracture modeling will actually, the information it can tell you, and you can then tell whether you need to change your properties and then do the modeling again, just to be rest assured that you are doing the right thing and you are doing it correctly. The next thing you can then do is to then plot all these properties that affect your fracture length and fracture height to see which of them is impacting your fracture length and height the most. And of course, you can use this tornado plot. And if you look at the tornado plot for both fracture length and fracture height, you can see the most influencing properties. And the major of them is the solid loading. The solid loading is this total suspended solid in your injection water. That plays the biggest role in determining your fracture length and height. Next is the injection rate. How much water are you injecting into your reservoir? Now, what this then tell you is once you have this picture, you then know which of the properties you can then regulate so that your fracture length and height does not grow beyond your reservoir and goes into your caprock. So you can do this sensitivity analysis, and then of course you can't change the ones that you can't control. For example, this amount of solids in your injection water, you can control that, and that means it would affect the type of surface equipment that you put in your system. Do you want a filtration system? Do you want a de-oiling system? How much filtration do you want to get so as to reduce this your solid loading in your injection water to as minimum as possible so that you can keep your fracture within your reservoir? And then your injection rate, how much do you want to inject? Can you do with more wells and you inject at a lower rate, or fewer wells and you inject at a higher rate? This is what this fracture modeling can, the information it can tell you, so that you can build a robust produced water injection system. This plot just shows you another output from this your fracture modeling. And what you see here is a plot between the fracture length and solid loading. And of course, on the y-axis too, you also see how many wells. And you can see that if you use only 2 wells, for this analysis, we were using 24,000 barrels of water, and we planned only 2 wells, injecting at 12,000 barrels each. And you can see if you do that with just 2 wells, injecting at 12,000 barrels of water per day, you can see the plot that your fracture will grow out of the reservoir and into the caprock, and you don't want that to happen to you. And what this plot shows you is that you can get better injection and still stay within your reservoir if you inject using more wells, injecting at a lower rate. And that's the information you can get from your fracture model. And then you can make that decision, of course, with cost inclusive, and see how many wells you can use to dispose the amount of water that you need to discharge into your reservoir. This is for the other reservoir, the C4 reservoir. I'll just, I've described what information this plot gives you and how that affects your design in full. The next thing you need to consider is how much water are you going to be treating over the years? For example, look at this plot here, shows you your water forecast. How much water are you expecting in the next 4, 5, 6, 20 years? And there are several tools that you can use for this. You can use the integrated production system model tool to make this forecast. And there are others out there. What this helps you to do is to plan and sequence your wells. So if you are going to be disposing 50,000 barrels of water in 5 years' time, and you are just going to be disposing 20,000 barrels today, that means you can just make do with 3 wells and then sequence to drill more wells in the future so as to handle the amount of water that you are expecting. That is what this does for you. So if you want to design a robust produced water injection system, you need the water forecast, how much water you are going to be handling in years to come. And another very important subsurface aspect is Sarin study. Now, what is, don't mind the lot of text that you have, but the summary here is you need Sarin analysis. Now, what that does is the water you want to inject, how compatible is it with the fluid in the reservoir that you are injecting into? So you have to do this compatibility analysis, because sometimes when you mix two dissimilar water together, you can have bacterial action leading to hydrogen sulfide production. And then, of course, you know how harmful and life-threatening H2S can be when humans are exposed to it. So you need to do this Sarin analysis, how much sulfate, phosphate, what is the pH, and all that compatibility test. So for this project, it was obvious that because we had not taken a sample from the two reservoirs that we selected, we did the analysis based on an analog sample. And then we did the test, and it was obvious that we are going to have some sort of sarin. And what that result then told us is that we should include a nitrate injection system, right, in the surface package, so that when that happens, you can inject nitrate into the water that you are injecting, so as to, it's like reduction, so as to serve to prevent this hydrogen sulfide production, because you are injecting into the reservoir. So that's the kind of information that the Sarin analysis gives you, and you have to do it in order for you to have a robust produced water disposal design. The next thing that is very important is corrosion analysis. You have to be able to tell how much corrosion you are going to be able to handle over the years. And the information that gives you is you can then tell the type of material you would use, the tubing material, the wellhead materials, even your surface pipe materials. Are you going to use corrosion resistant alloys, or are you going to use carbon steel and then put the thickness allowance so as to handle that that corrosion that you suspect, that you are going to be expecting over the duration of the well? And once you get that result, you can then go and put back your metal into a well cut analysis that then tells you whether your material will fail over time because it is corroding, and you are still going to be using it to inject water into your reservoir. So the basic thing that this tells you helps you to select the type of material that you will use to complete your well, as well as for the surface equipment that you are going to install for the produced water disposal system. The next one, okay, how do you want to complete your well? Do you want to put a sand control in? Do you want to put a permanent downhole gauge for pressure monitoring and all that? Do you want to put a subsurface injection system? How do you want to complete the well in general? This is what the well failure specification does for you. And then you can see a sample of a WFS that you put in your well proposal. The type of perforation, are you going to perforate? Do you want to do open hole completion and all of that? Very important when you want to design a robust produced water system. Now, when all that is done and you have completed your well, you want to start disposing, you have to then do injectivity testing. That tells you how much water can you inject into your reservoir. And what this does also give you is a baseline parameter, so that by the time you begin to inject, you can then compare injectivity over time with the baseline data, and you see whether your well is doing as expected, whether it is getting impaired, and then you can put plans in place whether to stimulate the well and get it back to produce. And get it back to performing at the optimum level. I've shown some plots here for one of the wells that we completed for produced water disposal. And when it started, injecting. And you can see the plot of wellhead pressures against rate, injectivity index against drawdown. And you have this baseline parameter. And then you can then compare your future data with this baseline data and check how your well is performing. Again, you can also make this plot and see how your bottom hole pressure compares with the fracture pressure. Usually there are some modes of operation. There are some who operate in the matrix mode. That is, they operate in such a way that the bottom hole pressure is just slightly below the fracture pressure. But sometimes as you begin to inject into your reservoir, the reservoir pressure would begin to build up, and with time, it could get to the fracture pressure of the sand and fracture it. In a way, that can be a very good thing, because when such artificial fractures are created, you can inject more. But again, like we have said in the previous model, you don't want this fracture to grow beyond your reservoir and grow into your caprock. So this kind of plots are always very necessary to monitor the performance of your well, as well as the change in conditions of your reservoir. Okay, so for this project, what did we achieve? If you look at this, the final few slides, where we were before, whenever we don't have our trunk line, how much liquid are we able to produce? And when we had this project completed, how much water are we able to inject and how much gas are we able to produce? And you can see the difference in that line. This is just for one well. And by the time the second well came on stream, you could then increase your gas production to maybe twice what you would have produced without that produced water injection system. So we have discussed some subsurface considerations for a robust produced water design, including reservoir screening, caprock integrity analysis, PWRF frac, the importance of water forecasting, Sarin analysis, and corrosion analysis, which help you build a robust produced water disposal system. All right, and in doing this project, we met the two objectives. First, compliance with DPR to pilot a subsurface disposal of produced water. And secondly, we are able to continue to produce our gas whenever our oil export pipeline is down. So the recommendation is to continue to produce this well. You need to monitor the performance of your well going forward. And of course, from our water forecast, you can then plan drilling of new wells in the future to handle the water that we expect. So that is the presentation. I hope I didn't go over time. I will take your questions now if you have. Thank you, everyone.
Thank you very much, sir, Mr. Umi, for that. Amazing. So Joy will take you up now.
Okay, thank you so much, Mr. Femi, for this insightful presentation. I think there's been a lot of information today, very useful information. So I'm taking the questions now. All right, so Darlington Ezekiel is asking, apart from injection pressure, do the water properties directly deplete the caprock integrity?
All right, thank you. So majorly is the pressure that affects it, and then the other thing is the solid loading. Like I mentioned, if you look at that plot, the tornado plot from the PWRF frac model, you'll see that the major factor that was impacting the fracture length and the fracture height was the solid loading. And what that means is the total suspended solid in your disposal water. If you have more solid, what that then means is that all the tiny pores in your reservoir will be plugged by those solids. And that means if you then try to push more liquid, you need more pressure to push your liquid into that reservoir. And then your fracture length and height would increase as a result of that. So there are many factors that play in the dynamic world that affect the behavior of your reservoir once you start disposing. But key among them is your pressure and then the solid loading in your disposal liquid.
Isra, can you please go ahead and take the questions?
Thank you very much. All right, so I'll be taking other questions now. Okay, so we have a question. On the whole, do you compare the injection pressure with the FIT of the wellbore for a suspected unconsolidated well?
Sorry, I didn't get that. You were breaking at some point. Can you take the question again?
On the whole, do you compare the injection pressure with FIT of the wellbore for a suspected unconsolidated wellbore?
Still not clear. I don't know. Can someone else echo that question?
You could actually, sorry, Femi, you could actually go to the chat area and read the questions yourself. Yeah, I think that could help. Yeah.
All right.
I can also read. You said, on the whole, do you compare? Okay, sorry, Femi, go ahead.
You compare the injection pressure with FIT of the wellbore for suspected unconsolidated reservoir, unconsolidated wellbore. Well, I think you meant unconsolidated reservoir, right? Yeah, so you do that. So usually you have your fracture pressure. You have so your FIT, if I get you, is your formation integrity testing. If I get your acronym correctly. Now, usually you have your fracture pressure, right? Which I think you get from your integrity testing, the pressure at which your formation will fracture. So what you do as you inject, of course, you know what your fracture pressure is. You install a permanent downhole gauge that can tell you what your new reservoir pressure is. So your reservoir has its own reservoir pressure. The formation has its fracture pressure, the pressure at which it will frac. As that reservoir pressure increases with injection, it will get to a point, it will fracture your reservoir, all right? So what you do is to continue to monitor that pressure. You want some fracturing, like I mentioned. If you create artificial fractures and fissures in your reservoir, then you can inject more. So fracturing is good, but you don't want it to go beyond your reservoir and extend to the formation. So yes, you have to continuously compare that fracture pressure with your injection pressure for monitoring purposes. I hope that answers your question.
Okay, thank you, Mr. Femi. Sorry, I had some technical difficulties. Okay, so the next question is it possible for the caprock to fail over time, even after passing the caprock integrity analysis? What recommendations could there be in event of this?
So you can do that, right? There are tests that you can do that can tell you whether, usually when you are injecting, when you do your, there are some tests you do that when you begin to inject, your pressure will rise and then it can fall off very rapidly, and you can tell whether you have fractured, you have fractured your caprock. But you don't want to do that, because once you do that, you cannot tell where your fluid will go into. But with this, your analysis that you have done, most times what we do in practice is, even though you have used a base case fracture pressure, you add a factor to it. So maybe 80% of that base case fracture pressure. So that gives you some headroom. And you know that you can never go beyond that pressure. So that you're not even very close to that fracture pressure. So mostly like this project, that's what we have, that's the stand we have taken. So because the low case fracture pressure is 4,008, we apply a factor of 80% on top of that. And we monitor that pressure, that it is not even up to 80% of the low case fracture pressure. So that way you have respite that you can never fracture your capro. I hope that's clear. So that's the recommendation that we normally give when you are injecting water into a reservoir. Yeah. Just take a factor.
All right. Okay, that's very clear. Thank you, Mr. Femi. On the average, how long does a disposal well last before the well begins to fail?
Okay, so there are several failures. Well, not like failure. The major problem, like this particular one, it was designed for up to 30 years. If you look at some of our oil wells, some of the wells have been producing since 1960, 1962, 1980. So 30, 40, 50 years, those wells are still producing. But the major problem that we have with water disposal is impairment. No matter how you filter your fluid on surface, you still have some solids. And sometimes even the dissolved ions in the water, like sulfate ions, carbonate ions, sometimes they meet different conditions downhole and they begin to precipitate. And then they begin to impair your formation. And that means your injectivity will reduce over time. And that's the reason why you get that baseline injectivity data when you are starting. So once you see that, you can go back and stimulate your well. And that means you go and treat it with acid solution, maybe HCl mixed with HF, just to dissolve those cakes around your perforations. And then you get your well to as new as you can get, and you begin to dispose again. But in terms of failure of hardware, no. And that is the reason why you do your corrosion analysis and you build all of that into your well design, and you are assured that your hardware will not fail over the entire life of that well. But impairment, yes, and that one you treat as you go. Yeah.
Okay, that's very insightful. Thank you. Next question. What are the risks of injecting a shallower sand where the sand is unconsolidated and friable?
Friable. Okay. Okay, so no risk really. Once you take into consideration your caprock, if it meets those conditions, you can inject into any sand, whether it has high porosity, high permeability, it has good properties or bad properties. For a robust design, just follow the outline I've described. Do a robust subsurface analysis, caprock integrity analysis, that you are safe, you can discharge, and then the conditions that enable you to continue to dispose in those reservoirs. So once you can stay within those envelopes, then you can dispose into any reservoir at all, as long as they meet your environmental conditions.
All right. The next question. Will the results of the PWRI assessment differ from an acidized well, versus one with some damage?
Of course they will. So if I go and take that, if you acidize your well, if your well is impaired, and that means your properties like permeability will change. One of the input parameters in your PWRI frac is your permeability. And that means if your well is impaired, your permeability may have reduced by 60% or 40% and 30%. And that means instead of putting permeability of say 2.4 Darcy, if your permeability, or maybe 2 Darcy, and your permeability is now reduced by 40%, instead of putting 2,000 Darcy, you go and put something like 1,200 Darcy there. Of course, that will impact your result. And that means that your fracture length will then grow faster than it should. But then if you have a virgin reservoir where the permeability is as pristine as from origin, then those are the kind of thing that you want. And if you have a fractured reservoir, then all the more better. Yeah.
Okay, that was very insightful. This question says, what are the impacts of dissolved solids in comparison with the suspended solids and oil in water in the PWD system?
All right, that's a good question. Now, your suspended solids, they have immediate impact when you start discharging. You know, when you discharge, just like when you are producing oil and gas, it is your fluid flow through the pore spaces. The pore spaces contain your fluid, and then it then passes through the channel. When you are disposing to, that is how your fluid going, you know, through those pores, those pore spaces. If you have suspended solids in your water that you are disposing, it will plug those holes. And when that happens, you are going to need more pressure to force your water into your formation. So that's the major impact of suspended solids in your disposal system. For dissolved solids, the ions now, the challenge there is you may then have secondary reaction with your fluid and they begin to precipitate. That's one. If they precipitate, they will have the same impact as your suspended solids, right? If they precipitate, they will have the same impact. So you want to keep them in solution. That's why if you think they are going to precipitate, you include in your surface disposal system injection of chemicals that would not allow such secondary reaction happen in your formation, so as to keep your ions in the solution, right? So that's one way you deal with that. And then the other impact of dissolved solid is you can then have bacterial action, and you have harmful gases being produced with your being formed in your reservoir. And if for any reason those fluids find their way to surface, maybe you want to go and do PHP, you are intervening in such a well, then you could have a problem where such gas rise to surface like H2S and have an impact on life. So those are some of the impact of suspended and dissolved solids in your disposal water. I hope that's clear.
Yes, thank you for that very clear explanation. Next question. How can possible sand phase failure be handled, especially when injecting at high rates for unconsolidated intervals?
All right, so two ways, right? Sometimes if you look at one of the sections, I shared the well functional specification where you decide whether you want to put sand control in place. That sand control, of course, helps you from injecting solids into your formation. And the other importance of that sand control is when you stop injecting. Now, usually, what makes you produce oil and gas from your formation? Where because your reservoir pressure is higher than the wellbore pressure. So fluid flow from your reservoir into the wellbore. The same way if you are injecting is the opposite. You want your wellbore pressure to be higher than your reservoir pressure. So you can inject into the reservoir. But the moment you take off that pressure from surface, which is helping you inject, so for whatever reason, maybe you don't want to inject for a particular time, then that pressure is taken off, fluid will rush in from your reservoir into your wellbore. And if your reservoir is unconsolidated, it will take solid into your wellbore. And those solids can have some impact. That means by the time you then begin to inject back, those solids will have to go back into the formation and they can plug your reservoir. So there are two ways to handle that. One, you can put a sand control in place. Two, if you don't want to put a sand control in place, you have a big sump so that once that sand comes, it drops into your sump. And that means you have to be intervening regularly. 6 months, 3 months, you just describe that cycle based on how much sand you are expecting. You can then go, you wash off your sand, and then you keep injecting. After some time, you go back, wash off sand, and then you keep injecting. Or better still, if you don't want to keep interrupting your injection well regularly like that, just to do sand clean out, just install sand control downhole. Like in one of our wells, we installed a sand screen in place and then installed a permanent downhole gauge just so that would not happen. Yeah.
All right, thank you very much for those very insightful and clear answers. So this marks the end of our question and answer session. So next we'll move to the recognition of our speaker appreciation.
Sorry, I had my hand raised. If I may,
okay. Go ahead.
just to Femi, very, very well done. To be honest, I learned a lot, and you're quite the depth in this talk, and the answers to the questions shows quite a lot of insight. I'm just coming from there. How could you link this no difference in fluid, both in phase, with CCS? Because the practice of CCS in company, in country, it's a bit reduced. But if we've advanced produced water in a manner you described, I know the materials are different, both in terms of fluid phase and also this kind of material. Just some thought on that. Then secondly, does this produced water, by chance, will it qualify for a producer injector pair? Say you want to use your produced water to flush your hydrocarbon, and you know, sort of, so you could push them into the producer well, so that you don't have to re-inject them. I get a bit wary if I try to wear my environmental hat, because I understand clearly we have a very young delta, and that will lead me to the third question. Do you have any model that could forecast, you know, take time lapse into another several million years to come? We're still in tertiary when our delta begins to mature, and then we'll have to wage against a fault-to-fault juxtaposition that could start and bring in some of this fluid that we are succeeding with smart technology in present day, because those stuffs could pose challenge to the unborn generation. You know, we've seen cases where source rock, you know, are not able to hold after several million years, and you see CPG self-crude, you know, in the shallow. What are the chances, if you've looked into such model, that in several years to come, when transgression, regression keep happening, as we understand today is just present day delta, it could be covered with water in the next million years. But what are the chances that this will not become the problem of the future? You don't necessarily have to answer them. They are just my random thoughts. But if you also have views, I'd like to hear. Thanks.
Yeah, a few very good questions, Jude. I would just take a stab at a few of them, and then the ones that I can't touch, then we can take them outside of here, right? Your first question on CCS, the carbon capture and storage, they are similar. You have to, but again, the know-how in Nigeria is still very in the early stages. Again, like you rightly mentioned, the fluid type and the conditions, unlike this unlike the produced water disposal, where temperature is not a very big factor in selecting. For example, how hot or cold the water you are disposing is not a very big factor. I know that carbon capture and storage is a very big one. Is a very big factor. So I would say there are similarities again, because it has to be a basin that can contain the fluid that you are injecting into. But I think there are more factors that are considered for carbon capture and storage, more robust than produced water. Yeah, that's what I can say. But again, few similarities in terms of reservoir selection and the surface equipment requirement. Yeah, for both of them. Your last question, if I remember correctly, is again, there is no way I can sit here and tell you and beat my chest and say it is not possible that what we are injecting will not find its way to surface in 5,000 years or 10,000 years. All right. So I can't do that. The same way, even in the natural world where you have a source rock, you have the trap. Sometimes you see how seepages, like you said, and sometimes we see that on surface seepages from and then underground blowout. So for this one, how we have tried to manage that to reduce the risk of that happening in one of our subsurface session was to stack all the reservoirs, not just the C2 and the C4, just stack all the reservoirs. Even though you have done the caprock integrity analysis, still stack all the reservoirs and see whether there is any fracture. Is there any fracture? Is there any fault, a natural fault, where your fluid can just ride on and then find its way to surface? So that's another check that usually done, which I didn't present here today. Just put all those stack from your identified reservoir up to surface and see if you have any of those faults that your fluid can ride on and find its way to where you don't want it to get to. And that's another check that gives you some kind of assurance that in the immediate, your reservoir, your fluid that you're injecting will stay within your reservoir. But again, like you said, in time to come when all the forces in nature begin to move down there, and then the fluid, your reservoir begin to shear and fracture and fault, that you will not have this fluid movement. Of course, like I said, I can't sit here and say that would not happen. But for now, we try in our design to make sure that in the immediate that would not happen. Yeah. So your third question, I can't remember that clearly, but I think I've answered 2 of your 3 questions. We can discuss outside now if.
Yes, indeed. For want of time, let's move on.
Yeah.
Thanks a lot.
Thank you, Jude. Well done. Good question.
Thank you very much, Mr. Femi. Thank you so much for all these questions, all the information. I want to sincerely apologize to everyone else. Some people are raising up their hands. Some people have some questions in the chat box, but because of time, we cannot take all the questions. But if you want to get answers to your questions, I'm sure Mr. Femi will be willing to answer them. So you can communicate with him, connect with him, and then get those answers. Thank you. So now we'll be moving on to appreciate our speaker. Okay, so Mr. Femi, on behalf of SPE Section 103, we want to show our sincere appreciation and gratitude for speaking to us in today's monthly technical meeting. You've contributed to us, and we just want to use this small gesture to show you our appreciation. So this is from SPE Section 103 to you. Thank you so much, sir.
Thank you. Thank you for having me.
Yes, sir. Okay, everyone, thank you to everyone that has stayed from the beginning till now, even those that joined us in the middle. We want to appreciate you. And at this point, we'd like to take a group photograph. So it's always good to keep record of the people here and at least remember this moment. So please kindly turn on your cameras. Let's all see your beautiful faces. Even if you're tired, just give us a few seconds, turn on your camera so that we can take the group photograph. Yes, please. Okay, that was good. I can see everybody looking stressed. Okay, let's give a small smile and take this. If I actually smile. All right, I think that's taken. All right, thank you so much, everyone. Okay, that's amazing. Okay, so I sincerely appreciate everyone, the speaker, the guests. You all are special because without each and every one of us, the guests and the speakers, this wouldn't have held today. So I sincerely appreciate everybody that has been here. And I'm thankful for this opportunity to contribute in my way to SPYP. SP section 103 YP. So let's move on to the membership drive. So at this point, I'll hand over to Ella to come and tell us how we can join SP or renew our membership. Hello, Emanuela.
Oh, hi, good evening, everyone. Thank you very much, Joy. Amazing session to our speaker. It was an amazing session. So I don't want to take much of the time because we're fast spending time. So I'll quickly go over to our membership drive. So basically, this membership drive is to encourage SP members that do not have up-to-date membership. Today is always the best time to renew your membership. And if you're not an SP member and you want to become an SP member, you can always reach out to me via LinkedIn or even reach out to the SP account on LinkedIn and we'll help you process your membership. I would also drop my number in the chat box. So there are lots and lots of benefits of being an SP member, not limited to just attending insightful sessions like this. We also go on field trips, there are mentorship opportunities, there are lots and lots of opportunities, but you won't have access to all these opportunities if you're not a registered member of SP. Currently, for the young professionals, we have a group chat where we share information, including updates on job openings. So these are the things that our registered members benefit from. And we want you to be part of the SP family. We want you to enjoy the SP community because it is a family. I never know talk too much. Basically, you can see my number on the flyer, the second flyer. So reach out to me. Or you can scan the barcode there. You can scan the barcode. And it will lead you straight to the website where you can process your membership. If you have any questions or you're confused about the registration process, of course, I'm always available to help you out. So thank you very much. Good night, everyone. Thank you.
Thank you for that, Ella. Okay, so let's have our technical team. Okay, so this is the YP Symposium. This is an upcoming event. I'm sure we're all excited. Anytime I hear YP Symposium, I get very excited because I don't like to miss it. So it's holding this year on the 14th and 15th of April this year. So 14 to be virtual, 15 to be hybrid. So plan to attend these events. Just try to clear up your calendar before then so you don't have any excuse. So next is the Kahoot section. So we'll call on Gerald, our Kahoot master, to come on. I'm sure a lot of people love this game. And who doesn't love a nice game? So let's test out our brains and hands. How fast are you and how much do you know? And then you could go on with prizes. Gerald, over to you.
All right, thank you very much, Joy. I'll be taking Gerald's place today for our Kahoot. Please confirm you can hear me.
Yes, you're clear.
All right, so it's usually the most exciting part of our YP MTN programs. So I'll be sharing my screen now, and you guys will see the details of the game. For everyone that wants to join the game, please just know what to do. Let me share my screen. Okay, just give me a moment. So I'm going to be dropping the link on the group chat now for everyone. So you can click the link and you'll join the game directly, or if you're on Kahoot, go to www.kahoot.it. Then you can input the game pin of 7684. So I'll be sharing my screen now for everyone to join in the account. All right, so I'm waiting for players now. Join in. Click the link on the chat box, or go to www.kahoot.it. Game pin. Today's game is going to be very exciting. We're going to be having knowledge from the presentation that we just had today, general knowledge on produced water, and then our general SPE knowledge as usual, because that's why we're here for SPE. So we already have Engineer C joining the game. We are just going to wait for a few more people to join the game today. So just join using the link on the chat box, or you can go to kahoot.it. You can visit kahoot.it. The link is on the chat box. Link, and then you join our game for today. Looks like we don't have regular people here. Okay, so waiting for a few more people to join in. We have our sustainability man here. We have Lori, Rosaline, Henry, Marcella. You guys can join in. Okay, Gold and Engineer C still on our game today. So I'll just wait a little bit and then we'll begin our Kahoot games for today. Anyone else that would like to join in can just click the link and then you'll be directed to the games. All right, so I'll give you a few seconds and then I'll proceed. Okay, we have Henzi joining in. All right, so we're going to have 3 people competing for the top 3 spots, and we'll see how this goes. So let's begin our games now. All right, first question, which of the following does not represent a typical elemental content of produced water? Are we looking at bicarbonate, antimony, helium, or fluoride? Our answers are in. Helium is the correct answer. Helium is not a typical element you would find in produced water. We usually have bicarbonate, we would have fluoride, and we have antimony. So let's move on to the next question. We have Engineer C leading the scoreboard. Who was the SP Section 103 chairman in 2021? Who was the serving Section 103 chairman in 2021? All right, we have one person getting it, Adibola Bada was our section chair in 2021. And let's see who got that correctly. Okay, we have Gold getting that correctly and then moving up to second place. So the next question on our ATC, where will the 2023 edition of SPE ATC hold? Okay, the next edition is going to be holding in San Antonio, Texas. We have had editions in Houston, we have had editions in Dallas as well. 2023 edition will be in San Antonio. Okay, we didn't have anyone getting that one correctly. So let's move on to the next question on our presentation. So which of these is not a criterion for choosing a hydrocarbon bearing reservoir or building a produced water disposal system? Okay, our answers are coming in. All right, so I think we got the correct answers on two of our players got it correctly. Reservoir pressure was not one of the things stated by the speaker today. It must still be deeper than the deepest underground source of drinking water. So we have Engineer C leading the scoreboard. Our next question, which of the following is not an SPE mission? This should be an answer that every one of us should know. Is it to collect estimates and exchange technical knowledge, or to provide jobs and internships? Okay, this is a dicey one because one of the options appeared twice, so I believe everyone should get this. That's correct. SPE is not here to provide jobs and internship, but to give you the platform to get things like this. All right, we have Engineer C still leading the scoreboard and Gold coming in close. Which of these? The next question, non-rejected produced water may have potential use. Is it false? Is it true? Is it probably, or we shouldn't just pay attention to it? What's our answer? It's our answer. All right, everyone chose true, and that's correct. Non-rejected produced water could have many uses, including irrigation for agricultural purposes and the like. We have Gold on the street for not meeting Engineer C. All right, so our next question, we're going to see in caprock integrity analysis, which of these models is best used when there is sufficient data? It was mentioned during the presentation. Which of these models would they mostly use when there's sufficient data? The dynamic simulation model is the correct answer. Okay, let's see who got that correctly. We have Gold still on the streak, and then Engineer C coming in first. So let's go to our next question, second to the last one. So who is the current Section 103 YP technical team lead? We're all supposed to know this. Mr. Basil is our technical team lead. Okay, we have Engineer C getting 5 correct answers in a row, still at the top place. So we have the final question. Which of the following is not a physical method for treating produced water? Coagulation, flotation, membrane filtration, gravity separation, or evaporation? All right, so we have some people getting picking up answers, but not correct. Coagulation, flotation is a chemical method and not a physical method. The other 3 listed there are physical methods for treating produced water. Thank you guys very much for joining in. And then we have Engineer C coming in first, Gold coming in second, and Hensley coming in third. Thank you guys very much for joining in today. You guys can contact our YP co-chair for your gifts. Thank you guys for joining us today. All right, so with that done, we're going to move on to our closing remarks from our technical team lead, Mr. Basio Bunide. So, Mr. Basio, please, the floor is yours to close us, and then we can take the national anthem and then close out for today's program.
Okay, good evening. Can you hear me?
Yes, you're audible.
All right, fantastic. So thank you everyone for joining today. It's been a very long one, but indeed it's been well worth it. There's been quite a lot of knowledge that has been shared. You know, the amount of work that Femi has shared here is something that you know, the people that know the work and people that know the value of what this has done, you know, not just in SPDC, but across the entire oil and gas industry, would understand the immense value that it is bringing. There is barely any company, you know, E&P that isn't talking about produced water, right? And how to dispose it, especially in our climes where we don't have proper, you know, evacuation routes that can be, you know, certainly available over a year period without any issues. So really, really great, you know, delivery and very insightful. I must say big thanks to Femi for doing justice to this topic. I certainly picked up quite a lot of insight, and surely there will be a lot more conversations, even for me, you know, following up to learn a bit more on this subject. And I hope it's the same for all of us that attended, right? SP continues to deliver, you know, a whole lot of value for us at an individual level, right? And there are quite a number of materials. I think there are papers even that have been written on this subject in recent times. I think last year or so, that you can even find on SPE1 Petro, you know, to learn about the value and how to even, you know, potentially apply this within your own space, wherever you're working. And of course, even if you're still, you know, fresh out of school and looking forward to getting into a company. I mean, if I'm a hiring manager and I get to interview and speak with someone that is already quite knowledgeable in this space and talking about the value this brings, you know, it's something that will bring pleasure, you know, to anybody in that space of a hiring committee. So please, by all means, you know, let it not end here. Continue to build knowledge and continue to grow as much as you can, right? And many thanks to the organizers of this program, the folks that have been working behind the scene, the committee, the YP Mama, the assistant, and everybody that has been making this happen, the moderator as well, a fantastic job, well done, right? So let's all continue to participate and drive SPE to greater heights. We have a number of programs coming up. I hope that we're going to continue to give the right attention to all the things that we do as we continue to volunteer. I think the next event is going to be in February. The next the monthly technical session is going to be in February. And of course, we'll push the publicity out as well to gain a number of your attendance as well, right? So I think with that, I'll say thank you again for attending, and we'll catch up again in the next one. Hand back to you now, Israel.
All right, thank you very much, Basil, my team lead. So to quickly close out this program, I would then just second stanza of the national anthem so you can follow along. Okay, thank you all for joining in today.